Welcome to this deep dive into the heart of econometrics. Today, we are exploring the most critical bridge between mere correlation and true causality. OLS Assumption Number 3, the Zero Conditional Mean Assumption. Formally written as the expected value of u given x equals 0. It sounds intimidating, but it is the secret sauce that makes linear regression work. To understand this, let's look at our classic linear regression model. Y equals beta 0 plus beta 1x plus u. Here, y is what we want to explain, and x is our explanatory variable. But notice the u. This is the error term, or the stochastic component. It represents every single factor in the universe that affects y but is not x. It's our garbage bin of omitted factors. Assumption 3 states that for any value of x, the average of these omitted factors must be 0. In mathematical terms, E of u given x equals 0. This implies two things. First, that the average error in the population is 0, which is trivial. But second, and most importantly, it implies that the error term u is not correlated with our regressor x. They must be independent in their behavior. Let's use a real-world example. The relationship between education, our x, and hourly wage, our y. When we run this regression, we want to know the causal effect of one more year of schooling on earnings. But what's in the error term u? One major factor is natural ability or intelligence. Here is the problem. People with higher natural ability often choose to get more education. This means as x, education, goes up, our error term u, ability, also tends to be higher. In this case, the mean of u is not 0 across different levels of x. It's positive for high x and perhaps negative for low x. This is a direct violation of the zero conditional mean assumption. When this assumption is violated, we have what economists call endogeneity. Because x and u move together, the OLS estimator becomes confused. It attributes the effect of the hidden ability to education. This results in a biased estimator. Our beta 1 coefficient will likely overstate the true benefit of education because it's soaking up the effect of the omitted ability. Visually, imagine a scatter plot. If the assumption holds, the data points are scattered around the regression line such that their vertical distances, the residuals, average out to 0 everywhere along the x-axis. If the assumption fails, you might see the dots drifting further up as you move to the right, meaning the error is systematic, not random. In summary, E of u given x equals 0 is the exogeneity assumption. It ensures that our x variable is as good as randomly assigned. Without it, OLS is just a descriptive tool for correlation, not a scientific tool for policy and causation. Mastering this concept is the first step to becoming a true data scientist or econometrician. References: 1. Wooldridge, J.M., Introductory Econometrics, A Modern Approach. 2. Gujarati, D.N., Basic Econometrics. 3. Stock, J.H. and Watson, M.W., Introduction to Econometrics.